Okey, Assalamualaikum dan salam sejahtera. Hari ini kita akan mulakan dengan bab yang baru, iaitu bab yang ketiga untuk kursus kaedah matematik gunaan, iaitu Fourier Analysis ataupun analisis Fourier. Sebelum kita pergi dengan lebih lanjut berkenaan dengan Fourier Analysis, mari sama-sama kita tengok apakah properties untuk fungsi ganjil dan juga fungsi genap ataupun odd and even function. Okay, so let us refresh our memories about even and odd function. Okay, this is because we shall use these properties quite frequently when discussing Fourier series later on. Okay, first we go to properties of even function. So recall that if fx is an even function, then we'll have f minus xx equal to fx. Okay, and the graph of an even function is symmetry about the y-axis. Okay, you can see that okay, fx equal to x square is an example of even function. Then when you plot fx equal to x square, you will have the symmetry graph about the y-axis. So this is y-axis, and you can see that your graph is symmetry about the y-axis. And it also can be seen from the graph that even functions have the properties, which is when you integrate the even function from minus a to a, you can simplify it to 2, and the integration will begin from 0 to a. Okay, from this graph, you can see because the integral is the area under the graph. Okay, so there is our graph. So when we calculate area, because it is symmetry, from this one, it is, let's say this is minus a, then there is a, then it is 0. Because it is symmetry, so we can simplify our even function. When you want to integrate even function, you can simplify it as this one. Okay. Okay, the Maclaurin series of an even function contains even powers of x only. Okay, so for this one, the example of the simplest even function is x square. Can you give another example of even function? Okay, answer this in Google Classroom. Okay, for these properties, for example, fx equal to x square is an even function. So we can see that, okay, so if you have minus x, so you will have minus x square. This one is equal to x square, which is, it is fx. Okay, so for all even function, the properties is whole. Okay, next we go to see the properties of odd function. So for odd function, we have these properties. F minus x equal to minus fx. And the graph of odd function is skew-symmetric. What mean by skew-symmetric? Okay, you can see this is fx equal to x cubed, which is an example of odd function. And when we plot this graph, so we will have skew-symmetric graph like this one. Okay, and then from this one, when we integrate our graph or our function, we will have this property. Okay, so let's see, because for example, you have this is minus a and this is a, or a in here is 2. So because the area, the integration is area under the graph, okay, so we want to integrate this area. And because it is skew-symmetric, skew-symmetric, so when you integrate it, it will become 0. But make sure the integration limit is from minus a to a. Okay, odd functions have the properties that their Maclaurin series contains odd power of x only. And the example of the odd function is, here is x cubed, so x cubed, and so on, is the example of odd function. And if fx is continuous at x equal to 0, then f0 equal to 0. Alright, so in here also, can you give another example for odd function Maclaurin series? Okay, so answer it in Google Classroom. Okay, that's all. Thank you.